Thank you. Hopefully we can make this work over Skype. I'm going to talk about the solutions that we at Gogo 6 have for IPv6. But first I want to start and backtrack a little bit and give my view on how to get to IPv6 and how we see the development happening to some extent. So first, we started out with an all IPv4 network, and hopefully that's where we are today. So we've checked this part off already, and hopefully already made us through this part, which is the IPv6 deployment in the core networks. So we're talking very much about an ISP network here, but it could also apply to a large enterprise or a university network or something like that, but which has a substantial network that operates more of a backbone and so on. So hopefully most people have made it through this point already and deployed it. And I think talking to operators and so on, we see it is the case. Most people have some sort of backbone and so on in place. And since we've moved so far down the line of IPv4, so we're already out of addresses in many regions already, the next step is going to be the trials that we're talking about right now. We have to start getting going. We need to get the experience and get things out there, because while building the experience is going to be hard. So what we're going to have is a limited deployment of IPv6 to get IPv6 out to select customers as a service, but mainly to build the experience of running IPv6 in the network and dealing with customers that are actually using IPv6. The next step, which is somewhat different than I think most of us envisioned if we go back a couple of years, and that is an IPv6 only access network with IPv4 running on top. The reason I say this is going to be the next step, in my belief at least, this is because we need to have a solution that addresses the IPv4 shortage. And that is going to be the first thing an operator has to address. The need to actually deploy IPv6 might not be strong enough for some players to do this. So instead of looking at a solution where we can deploy a new network in this manner instead. So what we have here is that the new customers being added in a way that conserves IPv4 addresses as much as possible. So instead of building this, I mean, in some cases, people are going to use a whole bunch of NATs and solve it that way. But more forward-thinking operators might choose to go and deploy IPv6 at the same time and use that platform as a way of moving forward. So it's getting the service into the home. And as I think you've heard already, I mean, big issues with these kind of deployments is to have the capacity of getting it into the home. So you need the equipment, the CPs, that can manage both an IPv6 native network and connect to that and make it work, but also handle the IPv4 service on top of IPv6. So this is one of the big challenges for deployment today, to have this kind of service. When we're moving on, we're moving into the next phase. IPv6 becomes more and more part of a real world on the internet. We see more and more IPv6, and suddenly there's a need for us to add IPv6 to our customers that are out there in the network, not just as a trial, but as real deployments. And once again, we're talking about getting it out there. Setting up a tunnel and so on is fairly easy, but the question is, how do you manage the customer deployment? And how do you do it on the customer side? And that's going to affect very much the solutions you're going to pick. Can you manage your customer CP? Can you do an upgrade of it remotely? In that case, you might choose to do 6RD. If you can't, you might have to do something else and work around the issues that are caused by the customer's network. I mean, it's especially complicated when you are in talking about customers that are already deployed, they're already set up. Then we're going back and changing something in their deployment. This is eventually going to evolve into becoming more of a widespread IPv6 deployment. We start out adding it in certain markets, certain customers, and then rolling it out to more of a general deployment of IPv6 throughout the network. At the same time, also, of course, hopefully the number of customers will continue to grow, so we continue to add new networks based on IPv6 only. There might be some upgrading going on, so we see an upgrade of existing platforms to become either dual stack, especially for like enterprise customers and so on. That would be the way to go. But for residential customers, it's probably going to be something more like an IPv6 only network with DSTM or DSLite on top. What's been interesting in these kind of deployments is that the traffic patterns are very different. When we do an IPv6 only network today with IPv4 on top, the majority of the traffic is still going to be IPv4 traffic. So most of it's going to be going through this tunneling machine. But as time moves on, traffic is going to go the other way around. There's going to be more IPv6 and less IPv4, which is a bit different if you look at it from a growth perspective than what we normally see, since we're going the other way around. We start with the peak traffic and then slowly go down for the IPv4 on this part. And the reverse is true for the IPv6. We start out with having people connected, but not much traffic, and over time, it's going to go the other way around. So we see it as this is going to affect the way you deploy, especially tunneled solutions, since your traffic patterns is going to change so drastically over time for the same number of users. I have no idea if you could see that, but there was just a little animation to show how we now move things around in the network. We started out when we started deploying the tunnel, like the IPv6 only network with IPv4 tunnel on top. We need to provide the tunneling service as far out in the edge as possible to keep the performance up and make routing optimal and so on. But over time, as v4 traffic goes down, this can be more and more centralized, as we're still going to have tons and tons of users connected that need some sort of IPv4 connectivity, but their overall volume of traffic can become very small. I mean, if you look over time, in like 10 or 20 years, it might be just a few % of the traffic that's IPv4. But everybody's still going to need some sort of IPv4 connectivity because they have some legacy applications or an old Xbox or something like that that needs that service. So it's still important to provide, but in a different way. And then the reverse is true for the IPv6. We have moved them out closer and closer to the edge because we want to optimize the performance, and when the network is more and more mature, so we can switch over to native IPv6, we move the last hop further and further out. So that's to give you a bit of a background on my view on the evolution. And I think this is a bit of perhaps a strange view or extreme view if you go back a little bit, but I think it's becoming more and more true since our world is a bit different now, since we're really feeling the pinch on IPv4 shortage, and that changes how we have to go about dealing with IPv6 and what is the real driving force behind it. Just a few words first about Gogo 6 and who we are. There are two parts to this company. I mean, it's an IPv6 focused company. That's the only thing we do. We only do IPv6, but we do it in two different parts. One is GogoWare, which is our actual products for doing IPv6, and then the other part is gogoNET, which is the social network that's to promote IPv6 and the reason why you guys are here today and listening to all these presentations and learning more about IPv6. Part of that is also the Freenet 6, which we do with our partners, which is the free IPv6 tunneling service that we do to help promote IPv6 and get people using it. So if we dig into the actual products for rolling out IPv6, I think we could say we are the only company that actually provides a complete solution with both the server end or the network end and the home end of a deployment with both the server and the client side, which is equally important in order to actually get IPv6 out there, or to be able to run IPv4 on top of an IPv6 native network. So we have the Gogo server, the Gogo CP, and the Gogo client. In all of these products, we do a mix of protocols to be able to do this. It's all based on tunneling or an encapsulation of some sort. So we support DSLite, TSP, DSTM, and 6RD. And we see it as these protocols are pros and cons in different ways. And by mixing them and using them, depending on your needs in the network, you can get the most out of your deployment. And I think that is the important part that people have to look at. What do we need for this specific deployment? And a lot of it boils down to how do I get it out to the customer? So if we take a quick peek on the pros and cons of the different protocols. For example, TSP is flexible in the sense that it's easy to deploy. You can put a tunneling client behind a NAT, and it will tunnel through and get you V6, and it works. 6RD is great in the sense that it gives you peer-to-peer capabilities within your network to optimize traffic flows that way and reduce the amount of traffic that has to go through a server. But it gets complicated because you need to be on a public IP, or public within your domain, at least IP, for it to work, which means the deployment part of it is a bit more complicated. Especially if you're going to deal with an average customer that has to do something to change their actual network to get it out. So this affects very much how you can go about deploying. So that's why we see that there's a mix of things. And the same is somewhat true in the other protocols to provide IPv4 over IPv6, which is DSTM and DSLite. DSLite is nice because it's a very lightweight, and there's no tunnel setup, there's no states except when people are actually sending traffic. But it's a bit more limited when it comes to controlling customers and assigning addresses and prefixes and so on to customers. So once again, it's a matter of what you need for the specific customer group, or for that matter, it could also be for your deployment within your enterprise. What do you need for this specific group of users or specific devices when it comes to getting the service out there? So the Gogo server is our solution for the network side of it, for getting IPv6 out there. So it's a tunnel broker that does V6 in V4 or V4 in V6, as I said, with a different set of protocols. It's a lightweight box, but that scales up to a lot of users. So the idea is to fit in with the concept of a changing network. You want to be able to support a lot of users when there's not that much traffic in the early stages like now, and also in the end when we get to IPv4 and you migrate in towards the core. So that's the idea. What can I say more? But it supports all the other things that you would expect of this kind of box for logging and authentication and so on. In the case that you actually use a protocol like TSP that supports it, you can do prefix delegations and both V4 and V6. Also, it's somewhat depending on what protocol it changes a bit, and so forth. As I talked about before, it's very much about the changes in the network, and that's what we were trying to address. It's to provide a tunnel server that can fit the different scenarios and be scaled by placed parts of the network. So we start out with small amounts of IPv6 traffic, a lot of users, and a lot of traffic on IPv4 and not so many users. So it's the different places in the network where it has to fit in. And that's the traffic patterns change. Box has to be able to change, or deployment has to change with it. The next part of the puzzle, which might be the most important part of the puzzle in many cases, it's the Gogo CP. And we call it a plug-and-play IPv6 adapter, in the sense that in the case of doing TSP, you can ship it out to a user, and they plug it into the existing network, and you got IPv6 enabled on that. So it's an upgrade to existing networks. And the idea that it's to help deployment, to make it easier to roll out. It also supports DSLi and DSTM, and there's also a 6RD version for special cases. If you look a bit closer on the IPv6 version, or IPv6 version, which is the version that the IPv6 in an IPv4 dominant environment. The idea, as I said, it's to help the IPv6 rollout. And usually it's the case when an operator has a home router that they don't control, it's the user's home router, or that can easily upgrade. So they don't have a remote management of it, so they cannot really push a new software out to upgrade it. This is where when the Gogo CP comes into play, because it gives the operator a choice of solutions on how to move the customer to IPv6. It's not that it has to be the exclusive solution, but it's more see it more as a complement in a set of solutions that you would do for this kind of rollout. So it depends on where the customer is in the cycle and so on. And if you have a choice of upgrading the router, they don't want an upgraded router because that means they have to go in and change their Wi-Fi settings and so on. So it's to be able to provide a set of choices to make it as easy as possible for the customer, the end user. This comes in a TSP and LTP version when you get this kind of deployment. As I mentioned, it's a 6RD version, more to cover special cases or special scenarios when you have a device or a computer that cannot be upgraded to support 6RD. So it could be in an enterprise environment or a campus environment. When you have a device that needs to get V6 using 6RD, but you cannot get 6RD functionality on that device. So this is like a in-between device kind of case. If we look at the Gogo CP v4 version, which is DS Lite or the DSTM versions, the intention here is to use it when you roll out an IPv6 only network. So you roll out a new IPv6 only network, but you need to provide legacy support. It's quite obvious, I mean, today that as an ISP, I mean, there's no choice. You always have to have IPv6 support. I think it's even true for an enterprise. It's very hard to switch to IPv6 only, even if you do like translation and so on at your edge, and you have most of your application. You're still going to have something that's going to require IPv4. That's you're more or less stuck. There's some application that says you need a way of working around it. And for SP, the Gogo CP in this case is going to work as a complement to a new home router. So if you have an existing customer that is getting upgraded to the new IPv6 only access network, you might give them a Gogo CP instead of a new home router to allow them to keep the setup as it is. Because it's important to understand that for a lot of users, setting up a new home router is a lot of work. I mean, for most of us that are here, or at least you guys who are there, and me being at the distance, it is a bit of a different story. We might think it's nice to get a new home router, but a big majority of users out there, having to change your Wi-Fi network is pain enough for them not to want to do it. And that's where it plays a role in providing flexibility. It is also for in the case you have a limited use set, you only have one computer, which is also a set of the users out there. The intention of it is also to be used as a set in the kind of enterprise campus environment when you have limited sets of computers or devices that need for legacy support, but we cannot really go in and upgrade it. It could be like a printer that you have that's not upgradable, so you use this to make it for, or it could be some old computer that you have that won't have the ability to run any of these solutions and doesn't support IPv6, then you use this kind of solution instead. A version of the Gogo CP, you could say, or the Gogo CP is a version of the Gogo client, which is a software version of the Gogo CP that you can install on your computer. It all exists in a couple of different CPs. And what it does is it's mainly a TSP client. On Windows, it's also a DS Lite client. So you can choose if you want to use TSP, DSTM, or DS Lite. And this is an open source client that we provide to help operators and device manufacturers get IPv6 support in their devices. So to summarize this, what is changed the deployment model, and I think it's also affecting what products we need today, is that it's the address shortage that's driving us to IPv6. And I believe, and I hope to some extent, that it's driving us to IPv6 only access networks when it comes to new broadband provider deployment. We have a whole set of different technologies to do this, and I think it's going to stay that way, and I think it's going to be useful because the different types of network we have today require different solutions. We cannot really stick with one solution. I think it's going to work in all cases. It's going to be a little bit of everything because the different cases are so different. As I said, we're starting out with all traffic IPv4. Even if we deploy IPv6 today, it's not like everything is going to switch over and suddenly become IPv6. This is going to be a gradual process. IPv4 support is also something that's going to have to remain for a long, long time. Especially true if you're an ISP, because you cannot really force your customers to get rid of all devices because you want to switch to an IPv6 only environment. For an enterprise, you might do something like that, but you have to keep in mind that you might have people coming from other places working in your network, and you have to be able to support them somehow. IPv6 will eventually grow and become dominant traffic in your networks, but it's going to take a while. So we need all these solutions to keep things going and working around the IPv6 deployment, and that's what we're trying to provide. Thank you. That's all I had.